Let's continue where we left from. I'm gonna share. By the way, this time I'm using another data, so numbers are different. Don't get confused, because in that example, I just calculate them to show you how to do it. But I didn't do this SCS or direct runoff or flood rating methods. I didn't apply them, so I'm gonna use an old one just to show you. Okay, once you get this excess rainfalls in terms of centimeter per hour, what you need to do is you need to do SCS method so that you can get your direct runoff. Okay, so how can you do this SCS method? In your homeworks, you also did it. So you'll do the exactly the, what? Why my share screen is stopped? Okay, let me share one more time. Okay, you can see it, right?
Yes, hocam.
Okay, you'll do this exactly the same thing like how you did in your homeworks. I hope you did it by yourself. So basically, you need to find area. Okay, this total area is given to you, but if you go to, okay, let me show you this first. If you open this project design PDF, this area is given to you. Okay, you're going to use this area. You need to use this area. You can recognize from this Cypress flag actually, if it is complicated to find it. So it is, what's the name? Hamitköy. So I'm gonna download this one, Hamitköy Reservoir from Google Earth, because you need to get those areas from the Google Earth. So you cannot do these before you get rid of from the Google Earth. I'm not clicking anything, by the way. I just download it and I open the file. It automatically takes me here. Okay. So let's see, we are here. My angle is a bit different than the Bertolja. His one was like a bit more 3D view, but it's still okay. So why you need to calculate, okay, your total area is given, but the thing is, if you look at here from the side, let's say, the slope of this portion and the slope of this portion, let's say, are not the same. So we cannot use the same slope for all the total area, okay? You need to calculate one common slope by, like, let's say you will calculate this much area for this much slope, okay? For the slope of this portion. And then you'll calculate the slope for this area, because this slope of this portion and slope of this portion are not the same. You can actually check. When I move the mouse, you can see there is something called yükseklik, which means the height in English. You can see when I move the mouse, that height is changing. So height at this point is like something like 672. Here it's 200, it's almost 300, okay? So from this point to this point, we have a very steep slope. But here it is like 230, and here it's like 180. So the slope is changing. This is why, let's say, up to some point, you can decide it. You'll calculate one slope, and you'll calculate the area for that portion. And then from that point, let's say from here till the end of this reservoir, you'll calculate another slope, and you'll calculate the area, and you'll calculate one common slope for this reservoir. How you can calculate that one common slope? Basically, you need to do the area of this portion times the slope of this portion plus the area of this portion times the slope of this portion, and you'll divide it by the total area, and you'll get the one common slope for this all reservoir. This is why you need to come Google Earth and draw your reservoir boundaries. How can you draw it? Let me show it to you as well. You see this white line. When you open it, there won't be a white line. You won't see it actually. So let me turn them off. So basically, actually Bertoja explains it very good, perfectly, how to draw these lines. But you can come here and you can select this one. Okay. Then you see there's a reservoir here. You'll start from here. There's something like river, if you can see. This is a river, actually. You'll follow this one till the top of mountain. And then from here, you'll come back by following this another river shape, and you'll close it, okay? I recommend you to watch Bertoja's video. In one of those videos, he actually draws. You can, let me show you very closely. Okay, you need to come here, this one, this tab, you'll select it, then you can directly, I'm just doing left click right now. Like this. Let me go fast. I'm doing something like just arbitrary right now. Yeah, something like that, okay? Then you can get this area from the Google Earth. Your total area is given actually, but you need to divide it as well. Like, as I said, you can divide it. Sorry, not like this. Okay, let's say, come on. And again, if I say, no, you can drive one more time. Let's say this was your total area. Now I'm dividing into two pieces. Like, let's say you decided to divide it from here. You can follow the same path. You can actually even divide in the first place, okay? Then you can get the area and the slopes. How you can get the slopes, by the way. Bertoja explains all these things in his video actually, but let me show it to you. There's a ruler option here, okay? Let's say you want to get the slope between this and this point, okay? You know, I told you you can read this height. You can read height at this point, and then you can read the height at this point, and then by using this ruler option, you can get the distance, and by using the distance and the difference between heights, you can calculate the slope easily. Then once you get these common slopes and area and etc., you calculate these kind of things. See, this is mean slope. You'll get the CN, S value, T values, and discharge values. I'm not gonna go into detail for those because this is SCS curve method. If you open your lecture notes or your book, you can see how to calculate. These are just equations. These are just equations. You'll just apply equations for each of them and you'll calculate them. Once you calculated them, you will apply the SCS curve method. How? In SCS curve method, this T over TP and Q over QP values are given from, you can take it from internet or from our lecture notes. I think they're also given. Okay, it goes till 5. So once you find this TP and QP values, like this guy did, You will multiply these values by TP value and you will find your T values. And for Q, you'll multiply this column with QP values. You'll find your discharge values for OH. And once you find these, you can decide what type of increment you want. This person decided he wants 0.5 hours increment. Okay, so he did like this 0. If you want 1 hour increment, you can go 0, 1, 2, 3, 4, 5. You can go like that as well, but you can also do 0.5, doesn't matter. And you will calculate these discharge values from here. Let's say it's 0, it's 0. Okay, for when t is equal to 0.5, we don't have 0.5 here, right? So you need to do interpolation. So you'll take this value for this time, we have this much discharge, for this and we have this much discharge, and 0.5 is between them. You will do the interpolation and you'll calculate the this discharge value for 0.5. How you can do interpolation? You will basically, since 0.5 is in between those values, so it will be like 0.52 minus 0.5 divided by 0.5 minus 0.65 will be equal to the value we are looking for is between 3 and between 1.84 and 3. So you'll basically do 1.84 minus x divided by x minus 3. And you will find the x value from there. This is how you do the interpolation. So you find your OH values, okay? Once you find your OH values for the unit hydrograph, then you can calculate your direct runoff. How can you calculate your direct runoff? If you remember, you had these excess rainfall values, okay? So these excess rainfall values will be how these values shows how much you need to multiply these OH values. So let me show it to you on the graph. Basically, these are the excess values, excess rainfall values. I took them from here. Okay. So these are the excess rainfall values. Basically, you have 1 hour lag, okay, because in between 0 and 1, we have no excess rainfall, okay, so there is nothing. So it starts from here at 1 hour. So we have 1 hour lag, this much OH1. What is this? 1.87. So we have 1 hour lag, 1.87 OH1. So then we have 2 hour lag, 1.69 OH1. 3 hour lag, 1.33 OH1. This D1 is this one, D2 means this one, D3 means this one. It goes like this. You need to do for all these values because it goes till the 7 hour lag, okay? So as you see, when we come to the 8 hour lag, since it's 0 again. So basically your direct runoff will be summation of these values. So since there is nothing here, 0, nothing here, 0. It starts from here. The values are starting from at this point. So 5, you'll sum this one and this one, 16.11, sum this one and this one. It goes like this. So you'll find your max. This direct runoffs will be your inflow for the flood routing method. And this flood routing will be the last step of your Excel process. And after you finish this flood routing, you can start writing your reports. You can finish this process in 1 day. I don't want you to get low grades from this project. Actually, this is an easy project. So once you get this direct runoff values, the next step is to apply flood routing. For the flood routing part, the storage discharge values are given to you. Okay. Like this. You can basically copy paste them like we did in here. The numbers may be not matching because this project is an old one, so don't confuse because of it. So what do we need to do here? We need to apply flood routing. To be able to do it, first you need to learn how to apply flood routing. It's actually about your homework 7, but let me go summarize for you very easily. So these storage and discharge values will be taken from here. Okay, storage and discharge. Are they same? They are actually the same. We're lucky. So once you get this storage and discharge values, okay, you need to calculate 2s divided by delta t, 2s divided by delta t plus q, and 2s divided by delta t minus q. How can you do it? This delta t value will be your delta t, of course, and it is 1,800 seconds. Why? Because here we use 0.5 hours increment. If you were using 1 hour increment, so how many seconds are there in an hour? It should be 3,600. But since this guy used half hour increment, it has 1,800 seconds. So basically, what you need to do here is this S, this is our S, this is our delta T. So for this column, basically you're multiplying this one with 2 and dividing it by this time. But what happened here? There is something wrong. Let me check. Okay, there is nothing wrong. I just forgot that these are in terms of, this is not 50 meter cube. It's like 50 times 10 to the power 3 meter cube. Okay, this means that. So it's like, it's actually 350,000. It's like 50,000. This means 100,000, 150,000 meter cubes because of this number here. So basically, this is why he put 1,000 here, because 10 to the power 3 means 1,000. So basically, we are multiplying this value with 2 and dividing it by 1,800 seconds. After that, you are adding this discharge value to this one, because it's 2s divided by delta t plus q, and then you are subtracting from this value this discharge value. You are doing it for all of them. Okay, you need to do it for all of them, and you're gonna fill a table like this. Once you fill this table, then the second step comes. You are taking these values from here. It starts from 0 from your direct runoff part, 0, and it goes till 13.5. For your situation, it might be different according to your increment. It goes till like this. And what else you need to do? As I said, these direct runoffs now will be your inflows. What inflow is shown as is I. So you take them and copy here as inflow, and then you'll have something like I1 plus I2. You need to calculate, you'll write these 2 columns, then you need to calculate these 4 columns. How are you going to do is basically, okay, you'll have this one, this one, and that one, okay? When these are 0, these I values, these will be 0 as well. When there is a number starts, for the Q value, you'll start always with this outflow value, this Q value. Your first I value will be equal to your first Q value, okay? In between them, these numbers will be equal to 0. Then what you need to do is this number is equal to basically the first one, you'll sum it with this one, and you'll get I1 plus I2. For example, for this one, you'll sum 16.11 and 22.16, and you'll get this one. You'll fill this column like this, and for example, for this one, for this I1 and I2 for the third row, you'll sum 22.16 with 26.14, and you'll get 48.30. It goes like this. You're gonna fill this column. After that, I also told you this one, this first Q value will be equal to first I value. Then you fill this one. Okay. Then what you need to do is you need to draw this graph from this table. You're going to draw this graph like you need to do, you'll draw discharge, this discharge versus 2 delta S divided by 2S divided by delta T minus Q graph. You'll draw this one, but don't forget this Q will be on the y-axis and this one will be on the x-axis. And you'll draw for one, for the plus Q1, discharge discharge versus 2S divided by delta T plus Q. You'll draw these graphs. You'll take the equation of the graph. So these are basically your slopes. And for this one, minus Q part for this column, you are going to take this discharge, and for like, let's say you want to calculate this 2S divided by delta T minus Q value, okay, for the second row, okay? You are going to take this one row above, this 5.28, and you will divide it by the aim of this graph, because we are looking for this number. So you need to go to this graph, the graph which we used this parameter. When you divide it by this aim, sorry, the slope, you'll get this one, okay, 43.60. Then for this 2S divided by delta T plus Q, this means summation of this one, I plus I2, and this 2S divided by delta T minus Q. And when you sum this and this, you will get this one, okay? Then, lastly, after that one, after you find this value, 64.99, by multiplying this value with the slope of this graph, you can find this discharge. And you will repeat same procedure. For this one, you'll come here, you'll divide this value with the aim of this graph, you'll get this 52.32. You'll sum I1 plus I2 with this value, you'll get this value, and then you will multiply it with this slope and you'll get this discharge value, and you'll fill this table like this. Here, what you need to do is you need to find what is the maximum I inflow value, okay? It is 26.14. And what is the maximum outflow value? Which is 18.41. So attenuation means the difference between the maximum inflow and the maximum outflow, and the translation means the time difference between the Imax and Qmax. So you'll find these, you'll calculate attenuation and translation, and that will be the end of your Excel process. Then you need to write the report. Oof. Wow. I tried to explain it as much as easier I can. I hope it will be helpful for you. I know it's a bit complicated. I know it's a bit complicated, but Since we didn't have much time, I tried to summarize as much as I possible. If you have any more questions, you can just email to me, okay? It's a really, really simple project. I just show you how to process these Excel files. Like, it won't take more than a day just to finish Excel process, okay? It shouldn't be more than, I mean, it can take a bit time, but you can finish it in one day, I guess. And then you can write the report easily.
On the last page, from in the rightest graph, what was it? I cannot see. Is it necessary or?
In this one?
I cannot see your screen.
Ah, okay. Let me share it again. You mean this graph?
Yes, hocam. Inflow and outflow.
This graph shows the inflow and outflow. So basically this one and this one.
Okay, hocam. Thank you.
Any other question? If you have questions, you can also still email me. And I'll try to answer them as much as I possible. So this was the summary of your project.
You explained very well, hocam.
Thank you
so much.
Okay, if you don't have any questions, you can leave, guys.
Hujam, I don't know if you can hear me because I'm having some
Yeah,
internet issues.
yeah, I can hear you, Omar. Do you have a question?
Yeah, but I was just asking if this, because some parts it was lagging for me, I couldn't see well. Because having some internet issues.
This on class, but first I need to take permission from